example 2. We want to show the two vectors A and B that are in component form are parallel. In order to do this, you need to show that one vector is a multiple of the other one. Now, in order to do this, we start with the vector that has the larger numerical I component and the larger numerical J component. So I'm talking about 12 and I'm talking about 6. Ignore negatives. So clearly B has the larger numerical values for the I and J components. So we start with vector B and we copy it down and put brackets around its I and J components. So B is 12i minus 6j. What we want to do now is lift outside the brackets a suitable numerical value such that this bracket now becomes vector A. So how can we make 12i into 4i? Well, if we lifted out 3. Because if we lift out 3, 3 multiplied by what gives you 12i? 4i. 3 multiplied by what gives you minus 6j? It's going to be minus 2j. So start with the vector that has the greater numerical I and greater numerical j value, and then lift out a suitable constant so that the bracket now becomes the other vector. So what we have now is that B is equal to 3 times vector A. So one vector is a constant multiplied by another vector. Now we've just talked about multiplying a vector by a constant. Remember we said that when you multiply any vector by a constant, the new vector will be parallel to it. That is one of the conditions. So we have now proven that the two vectors are parallel because you're multiplying one of the vectors by a constant to get the other one. So since we multiply vector A by a constant to get vector B, then vectors A and B must be parallel. Not only that, but vector B will be 3 times as long as vector A. The I component of vector B will be 3 times the length of the I component of vector A. The J component of vector B will be 3 times the J component of vector A. And remember, their arrow directions will also be in the same direction.